Okay, hi everyone. How are you today? Yes, I'm waiting for uploading my point. Yes. Yes, are you there? You don't say anything to me? Only 15 students here. Do you hear me? I think you hear. Hi, thank you. Yes, say something. If you don't say anything, I understand you are not here. Thank you so much. I am fine.
Yes, hello.
What about your midterm? I think it was so easy and your grade is so good actually, and there are lots of 100 points. It is so amazing, and I'm waiting my file for uploading, so I am waiting. Is Hi Kamal. Let's do that. Let's check. Yes, our file is uploaded. End of the lesson, I will say something about laboratory. You know, we cannot go out, so today laboratory is cancelled and all laboratory lesson has been cancelled. So I will send you the video of each experiment and you will write a report and I will explain about that end of the lesson. So let's start our lesson with aqueous solution introduction, actually. Introduction to reaction in aqueous solution. You know that our solutions generally are we use the solvent is what's that? The water. Generally, we use that. Maybe we use sometimes we use the solvent is what's that? Organic solvent. It is not the generally, but sometimes because some molecules or some chemicals are not soluble in the water, so we have to solve that chemical in the organic solvent. But generally or usually we use water as a solvent, and we prepare some solution. For example, you will see in the video at the laboratory, for example, sodium chloride or sodium hydroxide solution with water and some molarite. And if we mix these solution, for example, sodium chloride and sodium hydroxide, when we mix these solution, they give us some products, and maybe precipitation or change in color. You know that from the chemical reaction. This is reaction. Reaction occur in aqueous solution. Look that picture here. One clear, that one, this clear colorless solution of what's that? This is, I think, cobalt 2 chloride. Okay, cobalt 2 chloride and sodium hydroxide are mixed. Okay, a blue here, a blue cloud of solid. What's that? This is solid cobalt 2 hydroxide is formed. Such precipitation reactions are one of 3 types of reactions considered in this chapter. We will see. This is, don't forget that, this is colorless aqueous solution is cobalt 2 chloride, and then the solution of sodium hydroxide are mixed, and then we get cobalt 2 hydroxide, but this cobalt 2 hydroxide is not soluble in the water, and this is the solid. Okay, don't forget that these are important things. And here, molecular view of water. Here we have the beaker in the water, and this is the there is a via in this water. This is the fish, and the blue ball is the oxygen. And for the A picture, water molecules, what are they? These balls, I showed that the last weeks about the ball colors. For example, the red color is oxygen, and white color ball is the hydrogen. And water molecules are closed in the liquid water. And then here in the B picture, dissolved. Yes, dissolved oxygen gases and nitrogen gases will be here. The nitrogen gases, blue one, and the other, for example, look at here, this is red. These are the oxygen gases. These molecules, both of these oxygen and nitrogen molecules, are far apart, separated by water molecules. Here, the nature of aqueous solution. If our solute provides ions in water and this answer is the no. That means the non-electrolyte solution. What is the non-electrolyte solution? What does it mean, non-electrolyte? And then if our solution provides ions, lots of ions in the water, this is, yes, this is the electrolyte. If our solution completely ionized in water, it is so strong, solution in the water, and if it is not completely ionized in the water, that means the weak weak solution. If you want to give an example about this strong electrolyte, weak electrolyte, or non-electrolyte, can you give me an example about this one? For example, if there is no any ions in the water, what is that? Which solution can be? Please think about that. Or strong electrolytes. There are lots of ionized in the water. Give me an example. Give me an example non-electrolyte for strong and for weak solution, weak electrolyte solution. Bitter non-electrolyte. Yes, non-electrolyte solution. Give me an example. Yes, I am waiting your answers. Please try to think. Yes, work your brain. I am waiting. This is non-electrolyte solution and strong weak solution. Give me an example. What's that? This is the sugar, I think, bitter. Yes, sugar is non-electrolyte. Yes, maybe. It can be. Yes, what else? Strong and weak solution. What are they? For example, lots of ions in the water. What can be? Non-electrolyte, H2. H2, what is that? H2, Moyat? I can't understand what's that. Yes, strong. Yes, that's right. Sulfuric acid is so strong because this is so strong acid. And sulfuric acids, if the sulfuric acid dissolved in the water, there are lots of hydrogen and sulfate ions. Weak sodium chloride may be no bitter. This is so strong. Also, sodium chloride so strong. Yes. What else? For example, weak some chemicals. There is a reaction, and reaction has not only the products but also reactants. For example, what's that? Ammonia. Yes, that's right. Ammonia is maybe weak solution. Yes, what does methane? Khaled said methane. What is that? This is the weak, strong, or non-electrolyte. I can't understand you. For example, methanol. Methanol is an example of a solute that does not provide ions in water. So we can call that this is non-electrolyte. If you put this methanol in the water, there is no any ion in the water. So we can call that this is the This is the non-electrolyte, methanol and water fixed. Moyat, yes, that's right. That is the weak. And if we have so strong acids or base, there are lots of ionizide in the water, and this is the so strong electrolyte solution. And ammonia or what's that? Ammonia or acetic acids, we can call. We can give that example. These are the weak electrolyte solution. Don't forget that. Essentially, all soluble ionic compounds and only a relatively few molecular compounds are strong electrolytes. Don't forget that. This is important. And most molecular compounds are either non-electrolytes or weak electrolytes. Don't forget that. Yes, let's check that one here. This is 3 types of electrolytes. Here there is no in a lamp. Here lamp lights up only the lamp fails here. The lamp fails to light up here, and I think this is the methanol one. And methanol, check here. This is 4 hydrogen, the white ball, and the what's that? The black. Black is the carbon atom, and the red ball is the what's that? This is the oxygen, and there is no any ion in this methanol solution, so the lamp fails. Okay, to light up. And the B lots of we have lots of ionizide in this solution, because, for example, magnesium chloride, I think, because magnesium 2 plus and chloride -1, and the lamp lights up brightly here, you see. And the C, there's a little ionizide here, the positive and negative. This is the, I think, yes, this is acetic acid molecule, ionizide, produce here. What's that? This is the acetate ions, and this is the hydrogen ions. Hydrogen, this is the H3O plus, actually, here. And these molecules are not ions, so this lamp lights up only dimly. We can call that. And here there is some reaction here. For example, strong, this is magnesium chloride, aqueous solution means, in the parentheses, means the aqueous solution, and this dissolve in the water and give us the magnesium 2 plus aqueous solution and chloride aqueous solution. Don't forget that these coefficients will be 2 because of that. And hydrogen chloride, this is the so strong acids, you know. If you put that hydrogen chloride in the water, aqueous solution, that will give us hydrogen and chloride. And look at here, this is acetic acids. Acetic acids is the weak acids, and if you put that weak acid in the water has not only that hydrogen and acetate ion, that has that has also has that these acetic acids. Don't forget that this three type molecule or three type chemical has in the water. Don't forget that. But here that first and second reaction has only that products in the water. But here, the third reaction has three type chemical in the water, has. Don't forget that this is important thing. And let's look at. Yes, for example, for a non-electrolyte, we simply write the molecular formula. For example, solution of methanol in water, we will write here the methanol aqueous solution. And in the solution, magnesium chloride, for example, 0.005 molar, we assume that the magnesium chloride is completely dissociated into ions because there are two chloride ions, and for every magnesium 2 plus ion. The solution is 0.005 molar magnesium 2 plus, but 0.01 molar chlorides. Don't forget that. And generally bracket symbol, we will see that for the concentration. Don't forget that this is the molarite or concentration of these ions. We can call that. And 0.005 molar means that the concentration of the spaces within the brackets. Don't forget that. And you know from the last 2 weeks, the concentration mean actually molarites. And we will that, for example, the magnesium chloride has 2 chloride ion, and we have to multiply that these magnesium molarite with the 2, because the chloride ion 2 times more than the magnesium concentration. Yes, here we have an example about that. What are the aluminum and sulfate ion concentration in 0.0165 molar aluminum sulfate? First of all, you have to write that reaction for aluminum sulfate. If you put that solid chemical in the water, this ions separate in the water. For example, look at that. The solid aluminum sulfate in the water. We have 2 aluminum cation and 3 sulfate anion we have. And look at here, be careful here. Aluminum sulfate coefficient, this is in front of the aluminum sulfate. There is no any number, and it means the one. You know that from that last weeks. This is the 1, and then aluminum coefficient, this is the 2, and sulfates, this is the 3. And if we want to find that molarite or concentration, don't forget that the molarite means mole divided volume. And we think that here the volume will be 1 liter. If we think this volume 1 liter, that means molar is molar equal with mole. Don't forget that. If we think that this volume only 1 liter, and you know that these coefficients, these are coefficients, tell us about the mole. Don't forget. If we write here the 0.0165 molar, molar equal the mole, we write here that one. If these aluminum sulfates 1 mole, aluminum sulfate has 2 aluminum, but we have 0.0165 mole. How much aluminum we have? If you multiply with the 2, you will find the aluminum concentration like that. And then if you multiply with the 3, you will find the sulfate ion concentration. That's it. This is so easy actually. Only you have to know this is the volume only 1 liter, and so because of that, the molar will be equal with the mole. and then you will write this mole and you will read the reaction and then calculate. That's it. This is your homework. Some students, I think the new students, still send to me email about the homework. If you listen my recordings, you will understand these homeworks only for you, for study, okay? You don't need to send to me these homeworks answers, okay? So only you study for your exam, okay, for your final, like that. And this is precipitation reaction. This is so important actually. And net ionic equation. If we want to write net ionic equation, first of all, I will give you an example like this reaction. And then check here the parenthesis. In the parenthesis, this is the aqueous solution. Yes, that's right. This is silver nitrate will be dissolved in the water. That means, and this is aqueous solution, but this silver iodide is the solid one. So this is not dissolved in the water. We can write. So we have to separate these ionized, okay, in the water. What are they? For example, silver plus, and then nitrate negative, aqueous solution, and sodium plus. This is the ionization because of dissolved in the water. The iodide, this is aqueous solution, but this is solid. Solid is not dissolved in the water. That means, so you write these. This chemical not changing, and then sodium nitrate here, this is the aqueous solution. That's right. If these aqueous solution, that means this chemical can separate in the water with their ionized. Okay, this is sodium and nitrate. And then look at this right side, and this is the left side, and we will find the same ion. For example, nitrate. There is a nitrate left side here, and there is a nitrate right side, and then they will go. This sodium, the left side the sodium have, and the right side sodium have, and only we had the left side only silver and iodide we will write, and then the right side we have only silver iodide solid, and this is our net ionic equation. Don't forget that. Okay, this is important thing. And we will write, we can write this reaction for net ionic equation. But if you want to write this net ionic equation, you have to know some rules. Okay, if you don't know some rules that I showed you, you cannot write this net ionic equation, because this is so important. Look at here. This is, I think, these are the solution of some some chemicals. The A figure, a precipitate of sodium, for example, this is sodium iodide, okay, sodium iodide solution, and then the B1, I think the B, what is that, silver iodide. This is not, sorry, this is silver iodide. So sorry, silver iodide we have here. If we that one and that one, actually this is example of That one, yes, sodium iodide and silver nitrate. Okay, yes, silver nitrate and sodium iodide added each other, that one and that one, they give us a silver iodide solid. Okay, insoluble. This is insoluble, pale yellow, or we can call that this is cream colored. This is silver iodide solid precipitated from solution here, that's C1. Okay, don't forget that. For example, look at, this is silver nitrate aqueous solution and potassium bromide aqueous solution that give that reaction give us some products. What are they? If you want to predict these reactions happens or not happens, you need some information about the ionic compounds. Are not soluble in the water or soluble or not soluble. So we have some rules, and you have to know that. If you don't know any about these guidelines or these rules, you won't do that reactions. For example, please don't forget that rules. Okay, first of all, salts of group 1 cations and ammonia cation are soluble. Okay, don't forget that. All of these cations, but group 1 cations, don't forget that. Group 1 cations, maybe some exception lithium atom, but you don't cross that chemical, and ammonia cation are soluble. And the second rule, nitrates, acetates, and perchlorates are soluble. Don't forget that. Okay, and the third one, salts of silver, lead, and mercury one are insoluble. Don't forget that. Chlorides, bromides, and iodides are soluble, but the silver, lead, mercury are insoluble with these chlorides, bromides, and iodides. And the fifth one, carbonates, phosphates, sulfides, oxides, and hydroxide are insoluble. But sulfides of group 2 cations and hydroxides of calcium, strontium, and barium are slightly soluble. Don't forget that these rules are very important to write reaction aqueous solution. Sulfates are soluble except for those of calcium, strontium, and barium sulfates are insoluble. Don't forget that these rules so important. Okay, don't forget these rules. Don't forget. Yes, if you want to write, I think you don't see that. If you want to write, yes, that reaction will be happen or not happen. If this reaction happens, what will give you these products? What are the products? Please tell me. You know that the bromides, please remember that bromides are soluble. Bromides are soluble, but some, for example, lead, mercury, and silver, these are not soluble. So, can you say me about that reaction? Please tell me. Bihter said, yes, silver bromide and potassium nitrate. Yes, that's right. But this is the solid or this is the aqueous solution. What are they? and that reaction happens or not happens. There is a reaction or there is no reaction. Yes, I am waiting your answers. Hey guys, are you there? Please say something, please write something. What is that? Bihter says some products, but these are solid or aqueous solution, and that reaction happen or not happen. Yes, I am waiting. Bihter said reaction happened. Yes, Abdul Bari, Ali Samer, Amara, Victor, Amir Muhammed, Anas Mustafa, Emre, Ertuğrul, Kamal, Khalid, Kübra, Moyat, Erik, Simon, Nada, Naser, Osman Khan, Rayan, Roşat, Sadek Muhammed, Uğur, Yusuf. Are you there? There is reaction, Yusuf. Yes. So you say something. What are the products? And these are solid. Solid. Which one solid? Moyat. Which product is solid? Yes. Which one is solid? Which one is yes, bitter. That's right. Silver bromide is solid, and then potassium nitrate is aqueous solution. And we have, if you want, we want right here this silver bromide, because bromide solution are generally dissolved, soluble in the water, but some, except some metals, what are they? These are silver, lead, and mercury one. Don't forget that. These are the insoluble. This is the solid one. Solid, and then we have the potassium nitrate here. This is the aqueous solution. And if you want to write here, this is aqueous, not aqueous solution. So we write here the solid one and potassium and nitrate here, and the aqueous solution. And then check that sides, both sides, we have the same ions. This is what are they? This is the potassium and that potassium and nitrate, and then nitrate, and we have only silver bromide and silver bromide we have. And we, if we want to write the net ionic equation, this is silver aqueous solution and bromide aqueous solution, and give us silver bromide solid. This is our net ionic equation. Is that clear? I think this is clear. I will pass. Is that clear? Okay. Yes, this is also your homework. This reaction, first of all, predicts this reaction happen or not happen, and then if this reaction happen, please write the net ionic equation. And then here we have an example. Yes, this is the solving. What is that? The solving. I'm so sorry, this is not your homework, actually. Yes, this is not your homework because there is no any writing the homework after that homework. Yes, predict. Please, we are doing this example. Sodium hydroxide and magnesium chloride aqueous solution. If we fix this, both this solution fix, And then we have what about the products, and this is happen or not happen. Yes, for A, think about and write something. For A example, think about and write something. First, you have to think these rules. For example, hydroxides are insoluble or not soluble. Think about that. And then write something. Actually, the first example I will do, the hydroxide actually are insoluble, but we have some cations with the hydroxide slightly soluble. I said actually sulfates of group 2 cations and hydroxide of calcium, strontium, and barium are slightly soluble, we said. So this is sodium chloride and magnesium hydroxide. Yes, magnesium hydroxide is not soluble in the water. So magnesium hydroxide will be 2. This is the solid one. And then, and then we will write here the sodium chloride. This is the aqueous solution because the sodium chloride dissolved in the water. And then if we want, yes, this reaction happens here. Okay, this reaction happens because we have the products, solid one, magnesium hydroxide. Let's do that net ionic reaction. Sodium plus aqueous solution and hydroxide aqueous solution, and magnesium 2 plus aqueous solution, and chloride 2 chlorides aqueous solution, and we have magnesium hydroxide here, the 2, so we have to write the 2, and sodium, if we write here 2, that means that this is the 2. Okay, don't forget that. Sodium plus aqueous solution and chloride aqueous solution. Let's check 2 sides, the same ions. This is the chloride, and chloride will be gold. This is 2, and here the 2. Don't forget this coefficient, very important. And for example, sodium will go, and net ionic equation, magnesium 2 plus aqueous solution, and then 2 hydroxides aqueous solution, and magnesium hydroxide 2 solid. Okay, solid. And here our net ionic equation for A. Yes, what about for B? What about for B? Barium sulfate and copper sulfate. Yes, that's right, but this is a solid or aqueous solution. Which one aqueous solution, which one solid? And this reaction is happen or not happen? Yes, you write the products, or you write the this reaction happen or not happen. Okay, not write the ions, not right. For B, sulfate, think about that. Sulfate, think about that. What are they? These sulfates and sulfates. Yes, I am waiting. I am waiting that. Barium sulfate and copper is noble metal. What else, Bihter? Why do you write like that? Yes, you write something. This reaction happen or not happen. If that reaction happens, what are the products? Yes, Emre writes barium sulfate and copper sulfate, but these are aqueous solution or solids. Which one is the solid? Which one is the aqueous solution? Say something. Doesn't it just no, this is this copper interacts. Bitter, always. Copper, yes. Moyat, barium sulfate. Barium sulfate, I think. Copper sulfate solid, yes, that's right. Barium sulfate, you write aqueous solution, but sulfate, yes, that's right. Sulfates are soluble, but we have some metals are not soluble. For example, calcium, strontium, and barium. Yes, Sadek. Thank you so much. Barium sulfate is solid, and also copper sulfate is solid. And we have only products are solid phase. Okay, don't forget that. If we mix these, the both barium sulfate and copper sulfate aqueous solution, we have only solid products. Okay, and yes, that's right. There is a reaction here. This reaction happens here. Okay, don't forget here. What about the C? What about the C? C actually with B vice versa, because all of these ammonium, this is what is that? These ammonium sulfates, zinc chloride ions in solution, and all possible combinations are positive, and negative ions lead to the water soluble compounds. All of these ions in solution, so there is no any reaction here. Okay, there is no any reaction. Don't forget that here this example is so good actually, and you will cross with in the exam. Okay, don't forget that. Yes, what about this is explanation of this example, and this is your homework. Yes, and practice example B, very good question, because there is a naming chemical, and then you have to write the formula of these chemicals name, and then you have to write reaction. This is so good example. Yes. Acid-base reaction. Yes, acid-base reaction. You know that I said Moyat. I said some rules. You have to know that. I think you didn't listen to me. The acids can be defined as substances that provides hydrogen ions in aqueous solution in the water. This definition was first proposed by Steve Arrhenius. This is not important, but you know that the hydrogen ions, the products in the aqueous solution, that will be acid solution. Strong acids have strong tendency for producing hydrogen ions. Strong acids are molecular compounds that are almost completely ionized in the water. And for example, like check here, the strong acids, hydrogen chloride, aqueous solution, give us to hydrogen aqueous solution and chloride aqueous solution. These are concentration are very important, and there is only hydrogen and chloride ions in the water. There is no any hydrogen chloride molecule, okay? So we can call that this is strong acids. Weak acids are molecular compounds. Actually, I explained to you in the beginning of the lesson, acetic acid aqueous solution. There are three type chemicals in the water. This is acetic acids, and then hydrogen ion and acetate ion. Three type. There is no only hydrogen. There is no only hydrogen and acetate ion in the water. There is also acetic acid chemical in the water. So this is the weak electrolyte solution, we can call that. And this is reversible reaction actually. Okay, if the reaction is reversible, that means the weak acids, or that means the weak electrolyte solution. Don't forget that. Yeah, this is the bases. These substances produce hydroxide ions in the water in the aqueous solution, and this is the only one side. This is the only one side. That means only give you the products. There is no reactant in the water. The sodium aqueous solution and hydroxide aqueous solution. And if the base is strong, this is sodium hydroxide base is so strong, and we have only sodium and hydroxide. But the weak bases, this is the ammonia aqueous solution with the water. This is liquid reversible reaction. That means the weak bases, and these ions we have get, and we can call that this is four type, not four type actually. This is, yes, four type chemical we have in the reaction, okay, in the aqueous solution actually. Yes. Acid-base reaction, acidic and basic solution, we can said. An acidic solution, generally hydrogen concentration is bigger than in the water, and hydroxide concentration. In the basic solution, hydroxide concentration is bigger than the other, and acidic and basic solution, careful that the pH, you know that the pH means the acidic and basic unit, we can call it. If the pH is the 7, that means the neutral solution. If this pH is bigger than 7, that means the basic solution. Is smaller than 7, that means the acidic solution. You know that actually, and you know the brackets here emphasize that is given, for example, hydrogen and hydroxide concentration. That means actually I explained that. Neutralization reaction. Neutralization reaction, actually, that reaction occurs between the acid and what's that, basic solution. Look at your acid and bases that give us salt and water. That's it. And if you want to write the ionic form, if we write hydrogen chloride acids for that and sodium hydroxide bases, and give us sodium chloride salt, because this is dissolved in the water, and we have the water, that one. Yes, when the spectral ions are eliminated here, these are some spectral ions, the same ions, the both sides. For example, sodium and chloride, we have get only hydrogen and hydroxide ionized in the water, and they give us the liquid water. Oxidation reduction reactions, some general principles we have. This is actually important. For example, yes, here iron trioxide solid and carbon monoxide gases give us liquid iron and carbon dioxide. This reaction happens in which situation? In with the temperature. That means the temperature. If you write anything upper in this arrow, that means this situation, this condition of reaction. Okay, condition of reaction tell us that sign. And here, if actually you know that if in the reaction, if there is a reduction, also if must be there is a oxidation also. Okay, oxidation and reaction must always occur together. Don't forget that. And generally we call that this is oxidation reaction reduction. Sorry, oxidation reduction reaction, or we can call that redox. Yes, here if we want to understand that reaction is redox or not redox, you have to check these chemicals, elements, ion. For example, look at here for the iron trioxide. You know that iron trioxide's molecule have zero charge. So you have to accule with zero this molecule, and you know that the oxygen always oxygen charge always will be -2, and -2 multiply with 3, that means the -6, and I want to do these molecules charge 0, and this iron only 2, multiply with which one? Multiply with +3. +3 multiply with 2, that means the +6. And these molecules charge will be 0. That's right. This is only like that. And here carbon monoxide molecules charge is also 0, and oxygen -2 and carbon +2 will be. Okay, and then here pass the right side, the product. Iron charge is, what's that? Iron charge. This iron charge, what's that? This iron charge, what will be? I am asking you. What will be this iron charge? If there is no any charge, that means, what's that? Are you there, guys? Please write something. Yes, Peter, this is the 0. Yes, what about the carbon dioxide? Carbon dioxide's molecules charge will be 0, and you know that the oxygen charge, this is the -2, this is not changing, never changing, and that carbon +4. And look at here, this iron 3+ from 3+ to 0. That means, what is that? That's taking an electron, 3 electron, and then reducing. Okay, reduction. And then let's carbon atom, carbon 2+. This is 4+. Here, that's giving an electron, giving 2 electron, and then oxidation. Okay, that's it. Is that clear? Or we can call that gains oxygen atoms is oxidation and reduction reaction in which substances loses oxygen atoms is reduction. Okay, this is an example. Yes, you understand that's clear or not clear? I think clear, because actually you know that. Okay. This is actually explanation of what I was saying, what I said. This is explanation. And here, this is the example. Yes, this is example. What's that? If this there is a oxidation reaction, please check all of these elements charge, and then is there any reduction or is there any oxidation? Yes, there is a reduction, redox reaction, but there is no any reduction or oxidation. There is no redox reaction here. For example, mangan oxide, this is -2, and the mangan will be +4, and this is the +1 hydrogen for the chlorides, -1. Here, +2. There is a what's that? That's gain an electron, and then reduction here. Oh, yes, reduction. And then for chlorides, chloride gases have 0 only, and here the oxidation here. Okay, and this is the redox reaction. And what about the B? Here, here the hydrogen phosphate molecules charge will be -1. Okay, so you have to equal these molecules charge only -1. This is -2, and you know that the hydrogen +1. And please calculate here +2, and you know you don't know the phosphor charge, and plus phosphate charge, and then -8 here is equal -1. Okay, if you want to find this x here, this is -6, get here +6, and that x will be +5, and this phosphor ion charge will be +5. Okay, and what about here that is not changing here because hydrogen and oxygen always will be the same. And what about here? The hydrogen phosphate for negative 2, you know that, and you know that positive 1, and you know that the y and y negative 8 will be will equal negative 2, and this is negative 7 gets here the positive 7, and y will be positive 5. Okay, and the phosphor charge will be positive 5 and the same. There is no any redox reaction. There is no any redox reaction. We stayed here, and then the next week we go on from that here. Okay, that is clear or not clear, that example? Before ending the lesson, I will say something. Laboratory course has been cancelled. Okay, cancelled. I will send you the videos of each experiment, and you will write a report. You will only write your report in Word. I don't accept write by hand. Okay, be careful here. Also, for each experiment, I will send you a workbook, and you can study that. Please don't write the same with the workbook. Some students, the last semester, write the same thing with the workbook. Okay? You don't do that. If you write like that, this is not acceptable. Yes, and I will some explanation in the email. Please check your email. And the last time, I think the Bihter mail, you will send all of your reports, and then Bihter collect all of that and then sent to me. What is that? I think the last day is 1st June. Okay, 1 June. Don't forget that. After that, after 1 June, okay, I don't accept your reports. Don't forget that. And I will write in the email and explanation that. Okay? Do you understand me? Because 30% is midterm, 20% is reports, and 50% is final. If you listen this recording again, and then you will understand so clearly. Yes, so see you next week. We stayed here, and then next week we start from here. Actually, there is a little part of slides, and then the other subjects we will go. Is there any question about laboratory or about lesson? I think you don't have any question. Are you there? Please say something. You have a question or not question. If you don't have any question, we will see you next week. Thank you so much, Bihter. I think you understand. You collect all of these. You have lots of time. I will upload it, all of these videos, laboratory videos, in this week, okay? In this week, I will upload it, and then you will listen, you will watch carefully, and then write. First of all, you write the general information about the experiments, but you don't write the same thing with the workbook, okay? Please investigate about the experiment with the Google, and then you write. And you write what we use, the chemicals or materials, and then you write the what we did this reaction, or we did the experiments, and the conclusion, very important, because some conclusion have some calculate conclusion, very important. Please write that. I think the preparation of solution, you have some calculation, for example, molarite. I think video has no any about that, but I wrote the blackboard, for example, 0.1 molar sodium hydroxide, how we prepare that, okay? So you have to check, or you have to control all of that, and then write your reports. Yes, see you next week. Take care of yourself.